Thanks for turning out for this session. Hope reInvent's been good for you so far. Appreciate you making the trek over here to Mandalay to hear us talk about SaaS and generative AI. It's kind of interesting every year when we sit down and think about reInvent and what we're going to do, and we're always asking ourselves like what new emerging technology or what new patterns are out there that we can talk about. And obviously, generative AI very much came up to the top of that list for us, right? We see lots of customers and lots of partners and other folks who are very interested in understanding not just how generative AI can like fit into their application, but specifically like what does it mean to bring generative AI into a multi-tenant environment, and what are sort of the nuances and things in our architecture that we would need to do to support the sort of workflows and the sort of architectural principles of SaaS. Specifically, like how do we offer tenants specific customizations and specific refinements that can sort of sit on top of the whole Gen AI experience, but still deliver unique experiences to our customers. And so really that was kind of the motive behind this talk, was we really wanted to just sit down and ask ourselves how can we sort of spell out for you the landscape of some of the possibilities, looking at all of this through the lens of what does multi-tenancy do to the whole generative AI story? How does it affect data partitioning and isolation and pricing? And then how do we take all these cool tools like RAG and fine-tuning and all these other generative AI constructs and marry them to the Gen AI experience? And I will say, and probably this is the disclaimer everybody's giving, this is certainly early days for a lot of this thinking, right? We're all sort of scrambling to figure out what's the Gen AI story across so many experiences, and SaaS providers aren't alone. And so our hope is today that at least you leave here with some sense of what some of the possibilities are. I would suspect if you hear this talk a year from now, there'll be a whole new range of possibilities. But at least right now, we can sort of equip you with a mental model for what it means to sort of connect multi-tenancy to this generative AI story. Now, in terms of who I am, I'm Todd Golding. I've been working in the SaaS space for about 8 years for different customers and partners. And I am very fortunate to be joined by James Jory on stage today. James and I are both old friends and co-workers here at AWS. James, do you want to introduce yourself? Hopefully your mic's on.
Sure, yeah. Thanks, Todd. I'm a specialist solutions architect in the AI/ML group at AWS. I'm also a retail specialist, and I've worked with a number of partners on building integrations of AI/ML services into their platform. So happy to be here with you today.
And James is the one who really knows the Gen AI story much deeper than I do, so he's very much my security blanket in this moment. But he's been very helpful in helping me pull together this content and present this to you. So I do want to start this. We'll get into the tech. I promise you, it's a 307-level session, by the way. We're not going to be popping up the IDE or writing a bunch of code in here, but we'll absolutely get into architecture details. But we have to set the table just a little bit here, which is, what's the fit to me between generative AI and SaaS? Like, where's common points of intersection that I think are areas that people ought to be thinking about how and where to apply SaaS to the generative AI space? And let's start with the broadest of all of these possibilities, which is if you just look at SaaS on its own has a ton of momentum. It has become very much a standard way that people are trying to deliver and run their businesses. Applications are now being built in multi-tenant models at a faster pace than we can keep up with. And so SaaS on its own has all this momentum as a delivery model, and now Gen AI is sort of being thrown into this mix as well. And my expectation is that Gen AI and SaaS will very much be connected to each other and as both the way to deliver applications and a way to introduce this whole new way to sort of enrich the experience of SaaS applications. The more specific area, and the one we're going to concentrate on a ton today, is what does it mean to deliver like targeted tenant experiences in a Gen AI environment, right? We have these LLMs, we have all these mechanisms that let us sort of generally ask questions of foundational models. But what does it mean when I want to offer a targeted experience to a tenant, and a tenant in a specific domain? What is it that I can do in a SaaS environment that says, hey, I've got this one unique SaaS environment, but all these tenants are consuming it in all these different contexts, and I don't want to treat them all as the same. I want to offer them unique experiences. And that's where we're going to dive really deep, in fact, today, and a big part of what James will be talking about as we go forward, and I think a huge part of the value prop of Gen AI and multi-tenancy together. The other thing we have to look at is pricing and packaging. And every time I say pricing and packaging, I think everybody thinks, well, that's that's like somebody else's, that's the business person figures that out. No, what you're going to see and what we're going to get into is like how you sort of implement your multi-tenant Gen AI environment will absolutely will influence the packaging and pricing options of your solution. In fact, what we'll see, how you measure consumption, how you attribute consumption, and how that ends up translating into a price in your solution looks very different in Gen AI than it does in other environments. So there's a lot to look at and a lot you'll have to think about in terms of how that finds its way into your architecture. The other area is, I think, a tad speculative, but I think in general, if you look at SaaS, we always talk about efficiency in SaaS environments. We talk about how we can move fast, how we can get all these great analytics and insights that tell us how tenants are consuming our resources, how they're just generally imposing load, and we emphasize over and over again the importance of having all this rich insights data. Well, it only seems natural that this whole operations and analytics part of SaaS is also going to be enriched by Gen AI. But I will say, I think we're still reaching here to figure out what are the great stories in this space. We're not going to actually cover this as part of today, but I do think it's on the spectrum of things that you ought to be thinking about. And then related to that, one you might not think of is people are using Gen AI in the tenant onboarding space. The whole life cycle of tenant management and how tenants go through their journey as your customer is being applied to the Gen AI space, or Gen AI is being applied to it to optimize how tenants move through. How do we identify when they're at certain points? When should customer success reach out to them? There's already good examples of people applying Gen AI in that universe. And then finally, the last and most relevant one of the bunch, and the one everybody's searching for in every domain, which is, what is the magic thing that I can add to my SaaS application that is Gen AI enabled that differentiates my solution? It either enriches features I already have, brings new features to the environment, or just extends my reach into a new market potential. And that's where everybody's focusing their time, is trying to figure out where that sweet spot is. I don't think there's one sweet spot here. I think there are many sweet spots, but I don't know that everybody's figured out what the patterns and the themes here are. I still think it's very much an evolving space. The other piece we have to do before we dig in is to sort of outline what the big moving parts of this experience are, right? Generative AI has this massive space. The services and the capabilities of AWS span a lot of the experience. But for our SaaS part of the discussion, there's some very specific moving parts of this experience that we want to focus on, and they are going to be the areas where we really dig deeper. Obviously, at the base of this entire experience is the bit everybody talks about: foundation models, LLMs. These are the hearts and the brains of our generative AI environments, right? These are the really sort of fundamental tool around which everything else is built. And then on top of that, we start seeing where like stateless generative AI services come in, right? And so this is where at AWS you'll see SageMaker and Bedrock both coming in, and these are sort of the APIs that sit on top of those foundation models. These are the entry points into the experience, and this is where you configure what you want to do with the models. This is where you configure the underlying experience of the foundation model itself. In some cases, you'll see how that works as well. But this is definitely where your front door to these experiences is. Then on top of that, you'll start to see, now I'm going to show me some of these sort of dashed boxes because they're optional. Because in reality, if I went back here, my entry point can just be this, right? I could come in through SageMaker, I could come in through Bedrock, I could consume some of these foundation models, and that would be perfectly fine. But as we start looking at the multi-tenant story of this, we're going to tell you, well, what tools do we have in the toolbox to help us here? And one of them is fine-tuning. Fine-tuning, and James is going to get in a lot of detail around what we can do with fine-tuning, but at this level with fine-tuning, we're actually going to customize the behavior of these foundation models. We're going to enrich them with tenant-specific context to take them beyond just whatever they can do for any customer and do something specific for one of my tenants. At the next level, you'll have what I would call injected context here. So this is outside the LLM, but what we're basically saying, and outside of Bedrock, it's what can we do at the front door to this experience where we can modify the request we're saying in? Can we refine the request we're sending? And this is where you see RAG come in. If you've been around generative AI, you will actually seen this. And this is also because it's outside of this world. This is where state and memory also come into play at this level. So both of those are sort of sit outside the universe. This is where we will detect something that needs to, like the injected into the experience, and then that will refine the experience for us. And then, of course, sitting on top of all of that is our multi-tenant SaaS application, right? And now the question is always going to be like, which one of these are using which patterns? Well, you'll see I've left lanes open intentionally here to drive home the point that I might just use fine-tuning. I might just use RAG. I might use RAG and fine-tuning. They're all, the mixing and matching of that kind of depends on the needs of your environment. But these are the moving parts of the problem we're going to be talking about today. And hopefully that gives you a little bit of idea where things land. Now, I do want to start with the simplest generative AI case just so we have a foundation for what it is we're talking about here. And this is as simple as it gets, right? So if I just want to consume Bedrock today and I want to write an app, I can go write my app. My customer can pose a request, either something that's surfaced more directly through Bedrock or through the services inside of my application consuming Bedrock. But either way, that is going to yield a prompt. Some prompt's going to go into Bedrock, and Bedrock's going to return a response to me. And Bedrock's just a stateless service. It's just going to process that request and return a response. And so if the customers on the left-hand side of this experience are all just sending the same response, or the same request, they're also going to be getting the same response. So there's nothing that's going to be unique to the customer experience on the left-hand side here. Now, if you take that same model and you push forward a little bit and say, well, yeah, but what does that mean now when we're in a multi-tenant SaaS environment? Right? Now I've got these tenants on the left-hand side, and these tenants, we specifically want to offer them a distinct experience, right? We want to say when tenant one comes in, if they come in from a specific domain or from a specific space, and they pose a question, we want them to get a targeted response back. If tenant two comes in with a variation of that same question, but from a different domain, we'd like them to have a unique experience. Right? So the question is, how do we layer that in, right? And so what we want to do is say, hey, tenant context flows in, and then as part of tenant context flowing in, before we go to Bedrock, we want to sit between Bedrock and this augmentation experience. We want to augment the request that goes in to Bedrock. So here's where we have this whole notion of how do we augment the request before it goes in? How do we somehow introduce all the context that will give a very tenant-specific experience. So now once that flows into Bedrock, we have the tenant-augmented prompt, and now when the response comes back, I get a tenant-specific response. And so for me, this is the highest level view of what could multi-tenancy look like in a generative AI experience. The reality is how it's augmented is wildly different from one solution to the next, right? So I want to just make this point a little bit clearer by mapping it to a specific example. Let's say I have an e-commerce solution, right? People make stores and shops on my e-commerce platform. It's one solution, everybody consumes it, they all consume it equally. But the customers who build stores on my e-commerce platform, they aren't building stores from all the same domains. Some are coming from the golf domain, where they're selling drivers and wedges, and their customers have very specific expectations about what it means to buy golf clubs. Others are selling tools, and they want like hammers and saws, and they want other sort of things. They want a unique experience relative to that. And then, of course, we've got clothing, right? So now if I have these domains, but they're all still running against my one platform, when they come in and they say, I want to go find a product, or I want to go find or search for something, but they're saying, oh, I'm a left-handed golfer, and I have a slice that's really bad, and well, there's probably lots of things bad about my golf game that would show up here, but which club might be a good fit for me for these particular set of conditions? I want to have that domain context injected somehow into the request that I'm going to make to the back end of this experience, so that I get back a specific response that is contextual to the golf domain. And now when the tools domain comes in and makes a request, I want the same sort of experience. So to me, this is both valuable in terms of the shoppers getting a great experience, but it's also a great way to highlight the fact that not everybody has the same expectation of what they're going to get back from Gen AI, and it's our job, especially in a SaaS environment, to figure out how to tailor that experience. So at this point, I'm going to hand off to James, because James is going to go ahead and take this concept and push further here into what do the specifics of this look like.
Thanks, Todd. So if we take this concept and drill a little bit deeper into using RAG, or retrieval augmented generative patterns with in a SaaS or multi-tenant application, what does that look like? RAG, purely speaking, the RAG is a pattern or a technique by which you improve the quality of and the predictability of the output from LLMs by grounding the LLM or providing additional data that's retrieved from an external source from the LLM, and you provide that in your prompt to the LLM to keep it focused on the task at hand. So the typical data source types for that retrieval layer is most commonly is going to be some sort of vector database, like OpenSearch with the KNN plugin, or Pinecone is a really popular SaaS-based vector database. Enterprise Redis added support for vector-based lookups. MongoDB did as well. So this is a rapidly changing space in the database community, is adding support for vector-based similarity searching. And the reason why vector databases work so well with RAG use cases is they're able to take a natural language query or a semantic query and be able to find similar or related documents in a semantic way, or objects in a semantic way to that natural query. However, RAG is not, it's not a requirement that you use a vector database. And we're going to show an example here of how you can use either DynamoDB or relational database to pull that or retrieve those facts or that data that can then be used in a prompt. So we have a scenario here of a tenant entering an application, a shared SaaS application, tenant number 5 in this case, and we're looking to build that augmented pattern that Todd was describing. So we go off and collect the products for tenant number 5. We're using a dedicated table here for this tenant. Maybe our use case is we want to take the currently promoted products for this e-commerce store, and we want to ask the model to maybe wrap those products in some marketing copy that promotes or makes those products look more compelling to the user. So we retrieve the product information, and then we augment the prompt. We build a prompt based on that product information, and then we instruct the LLM through the prompt what we want it to produce. Now, another tenant comes in to the same solution. So tenant number 4 comes in, and we do the same thing. So we make a request to tenant number 4's dedicated table, in this case, to retrieve its products, and then go through the same process of generating a prompt with tenant 4's products, and then return the response. Finally, we have a third tenant, tenant number 2, that comes in. And in this case, tenant number 2's data is in a shared table or a pooled configuration. So you can see here we're getting the partition key. So this is a DynamoDB table. The partition key is tenant number 2's tenant ID. And that's how we're able to just pull that tenant's products from that shared table. And we set this up on purpose to illustrate that a lot of the same SaaS patterns that you use for building SaaS applications apply here in a Gen AI application use case. So, a lot of those same learnings it can be applied to this class of new use cases and experiences you can build. So when it comes to selecting the data source that you're going to use with these RAG experiences, there's lots of different choices. So if you're going to do a vector-based type of lookup, so a similarity semantic-based lookup, OpenSearch, I mentioned that. You can also do it now with Postgres using the pgvector library. Kendra is another option. It's a fully managed service that can index documents that you have in S3 and other applications that you use. And then sort of a different one to consider as we're sort of teeing up this e-commerce experience is maybe instead of promoted products, I want to pull recommended products for this user based on past purchase behavior, and then be able to build a prompt around those recommended products. So the idea of showing just a few of these sources is that you want to match up the data store with the use case that you're looking to build. And you're not limited with vector databases alone. Some of the decision making that you need to go through is similar to any like transactional data source choices you make in a multi-tenant SaaS application. You're looking at the ability to partition your data, your tenant data, tenant isolation. You're also looking at operational characteristics, so noisy neighbor type situations. These are all important considerations that apply in this Gen AI space as well. So looking a little bit more closer at the vector databases, since it's so common with RAG and Gen AI, we're going to look a little bit closer at, well, how would I populate these vector databases in a SaaS-based application? So it starts with the tenant data. We're going to index that data in a vector data store. And a vector data store, if you're not familiar with it, it's a type of database where you index and store unstructured objects that are represented as vector embeddings. And then the idea for these is, as I mentioned, is to be able to do similarity-based searching, semantic-based searching. And when you query one of these indexes, you take a natural language query or a semantic query, and you generate an embedding from that query as well, and then you search the index for objects in that index that are semantically similar using vector-based algorithms such as cosine similarity. There's other approaches. You're basically finding vectors of other objects that are close or nearest neighbors to that query vector. So we have our tenant data here staged maybe in a data lake, and before we can generate embeddings on our data, we likely need to do some preparation here. And so this typically with text-based data, it's called chunking, where you're going to take maybe a long piece of text and you're going to break it into chunks, so you're going to generate embeddings for each chunk of data. You can use AWS Glue or EMR, a couple of AWS services that would be a good fit here. And then with your data prepared, you're ready to generate those embeddings. We're showing a couple of options here. In SageMaker is you can host a model, say from Hugging Face, that will generate embeddings based on the input that you provide. Bedrock also provides fully managed models that can generate embeddings as well. So these are two options available to you. Once your embeddings are generated, it's time to index those embeddings into, say, a vector data store. We're picking OpenSearch here. And you can see we have two different OpenSearch domains for two different tenants. This shows you how you can do a siloed-based approach with OpenSearch in this case. And so what's in our index is both the embeddings and the text, so we can do those vector-based searches. Amazon Bedrock, you probably heard a lot about it this week. It's a fully managed service that's designed to provide API access to foundation models. And one of the sort of higher level capabilities that Bedrock has is something called knowledge base. And it went GA this week, and it helps automate some of those steps, or it takes on some of those steps that we saw on the prior slide of sort of doing it yourself. So I want to walk through how you would do that similar process we just saw, but this time with a knowledge base in Bedrock. So we start with our tenant-specific data, and we need to create our OpenSearch index beforehand, because we're going to tell Bedrock to index our data into that index. OpenSearch serverless supports vector-based database, so you don't have to manage any instances or nodes. You can let the service handle all that for you. So the OpenSearch serverless is a great match here. So we're creating one for tenant 1 here. And then we ask Bedrock to populate that index and manage that index. It takes the data, prepares the data, and it calls the Titan embeddings foundation model to generate the embedding. So it does this on our behalf. We don't have to make that call now. And it will also index the embeddings as well as the metadata directly in that OpenSearch index that we provided when we configured the knowledge base. What's also nice about knowledge base is it provides a inference endpoint or a query endpoint where you can provide a natural language query, and knowledge base will generate an embedding from that query for you automatically, and it will submit that query to the OpenSearch index in this case and return the results. So it helps you both on building out and populating the index as well as querying the index. like to pivot a little bit here and talk about another capability of Bedrock that's common with some Gen AI related use cases and how we can use this in a SaaS-based application. So agents for Bedrock, it also went GA this week, allows you to tap into the reasoning capabilities of large language models, where a large language model is able to take a complex task and break it down into steps and execute those steps to perform or execute that task. Some examples might be creating an agent that can process insurance claims, an e-commerce experience where you want to guide a user or consumer through a purchasing experience and actually place that order, or helping consumers with travel reservations. There's really, the possibilities are endless. And these agents have the ability to prompt the user for the needed information to complete that task. So it breaks down the steps and it says, I need more information from the consumer. It will prompt the user, get that information and continue the flow. It can also call Lambda functions in your AWS environment to perform each of those steps. And finally, it can look up, if it needs data to complete the task, it can look up data, say, in a knowledge base, to be able to pull that data in, and it will compose a prompt to the LLM to continue through that task. So let's walk through an example here. It starts with bringing a task in, and we're showing here from our application, we're going to have some tenant context that identifies that tenant. So we're still, kind of keeping this in the SaaS world here. And that task is submitted to an agent. When we create an agent, we provide instructions to the agent. And so in this case, we'll use the example of helping Todd with his slice situation in golf. You are a retail assistant responsible for helping customers select and purchase golf clubs. So that's the role or the instructions for this particular agent. With the task provided to the agent, it's then going to compose a prompt to the LLM that includes all of the steps that it can perform, the context of the role, what its job is as a retail assistant for a golf e-commerce storefront, as well as the actions it can perform. And so that prompt is submitted to an LLM to be able to then perform what's called chain of thought, which is a reasoning action flow. It's a prompt engineering flow with LLMs that allows it to go through these steps. And it may go back and ask the customer for more information. So, are you left-handed, right-handed? Those kind of questions. And it goes through these sequence of steps by making API calls that you configure with your agent. So these Lambda functions can do things like look up inventory for a set of golf clubs, place the order, get the shipping tracking number. Really anything can be done behind these Lambda functions. And they could be, these functions could include your business logic, or they could just be shims that call microservices that you already have in your SaaS architecture. You can also look up data from data sources. There's really no end to what you can do. And as you see, the tenant context is passed through, it's weaved through this process. And so these Lambda functions then can know what the tenant is, they can have session identification, who the user is, that can all get passed through as session attributes through this agent process. The agent can also consult a knowledge base to be able to get information. So maybe we're looking up, we have a knowledge base of how do you match golf clubs to players based on their skill level, things like that. We can tap into a knowledge base and then use that to build a prompt to guide this entire process. We get down to the end of the steps, and we will return the results back to the agent. The agent has the results. It will take the task and the results and craft a prompt to create a final result, which is returned to the user. So something like, okay, we've ordered your clubs. It's these ping irons, and they're on their way. They should be there by Thursday. Something like that would be the end of that task or the results of that task. So we've talked about RAG. We've talked about different techniques there and using prompts and prompt augmentation. A question invariably comes up is, what if I reach the limits of what I can do with prompt engineering? Or what if my use case is so specialized or so complicated that one of the existing foundation models just is not adequate? You could certainly build your own foundation model from the ground up. but that's typically cost prohibitive and also beyond the skills of most organizations. It's a very big endeavor, very big process. What if you could take an existing foundation model, provide some additional training data that's specific to your use case or your domain, and then use that specialized model to integrate into your applications? And that's exactly what the process of fine-tuning is. And Bedrock, fortunately, Bedrock provides this as a fully managed experience for you. In fact, you don't even have to write any code. So the way you think about fine-tuning is there's multiple dimensions here that you can think about it. You could, at the tenant level, we could actually fine-tune models for each tenant if we wanted to go to that granular level. And that involves creating tenant-specific training data and validation data that we provide to Bedrock when we create a custom model, along with what's called hyperparameters, which are parameters that control the training process, parameters such as the number of epochs, the batch size, the training rate, or learning rate rather. These are all parameters that you can control in that training process. The output of creating a custom model is a fine-tuned model. We're showing two different models here for tenant 1 and tenant 2. These models are managed by Bedrock, and they are only accessible from your account. So these are still private to your environment. And we'll learn more about how you can control that through IAM later in the talk. Another dimension to think about is, what if I don't need tenant-specific fine-tuning? What if I want to do fine-tuning at a industry or domain level? So maybe I have customers in the healthcare and financial services areas, and I have data that I can use to fine-tune those FMs to create a better experience there. And so you can do the same process at an industry level and create fine-tuned models that you share across all the tenants for each of those domains. So looking at this more from a procedural or lifecycle process, just real quickly, you start with Bedrock, of course, and you invoke a custom training job. It's model customization job for each two tenants here, tenant 1 and tenant 2. We bring in the training data from each of those two tenants. And the output are two fine-tuned models, and Bedrock will associate a model ID with each of those models, and we'll see how we can weave those into both the onboarding process and the request flow. So moving forward into thinking through the onboarding process with both RAG or fine-tuning, or both. Let's take a closer look at that. So we start with a tenant that's going through some sort of onboarding process. This could be an onboarding process that's managed internally in your application, or maybe the tenant is sort of driving this onboarding process. And we'll sort of use the classic SaaS approaches here and design patterns of having a control plane here with a service, an onboarding service that's the orchestrator for this onboarding process. It works with a tenant provisioning service to perform all the provisioning tasks. And maybe that service reaches out and provisions some of the other non-Gen AI pieces, running parts that we have of this architecture. Where the Gen AI comes in is then we can initiate that same fine-tuning flow. If fine-tuning is part of our, at the tenant level, is part of our solution, we can kick off that process, as well as populating that vector database. So if we're going to use like an OpenSearch vector database, we can begin that process as well. Both of those two processes are asynchronous in nature. They're typically something you're going to kick off and it's going to end at some point later, and eventually will be ready for your tenant to start consuming those specialized resources. We need to store that tenant configuration somewhere, so we'll interface with a tenant management service that stores the model ID from our fine-tuned model, as well as maybe where our training data is located in S3, maybe where our RAG OpenSearch index is stored. We'll associate that with the tenant in the tenant management plane. Now it comes to routing requests that come into the application. So again, we'll start with tenant number 1. The request comes in with tenant context that we'll use to associate this user with a tenant. We have an application plane, a service that's processing these requests, And the first thing it's going to do is look up or resolve the information it needs for this particular tenant from the same tenant management service that we saw on the prior slide. With the RAG information that we have here, we can reach out to that RAG data source, whatever that is. If it's a database call like we saw with those DynamoDB tables, or maybe we want to do a query to an open search index, bring back related documents or items, that's what we do there. In order to invoke that model, we need the model ID for the fine-tuned model, so we'll also get that from the tenant management service. Now we're ready to build our prompt and pass that prompt to the model, invoke the model with that prompt, and receive the response back that we pass back to the user. So when you think about fine-tuning and RAG, there's a lot of decisions here, and there's no absolute rules here. It really depends on working backwards from the user experience and use cases you're looking to deliver with Gen AI. You may be able to use a single fine-tuned model across all tenants. Maybe you fine-tune one FM and you use another FM sort of off the shelf from Bedrock for a different use case. Maybe you're going to use some of the knowledge base or the agents for across all tenants in Bedrock. Or the other way, maybe you want to do that tenant-specific fine-tuning. You want to do tenant-specific RAG. There's really no really exact guidance here, but you can mix and match these in different ways. And so that's really the hard part of thinking about Gen AI, incorporating these different technologies, is combining the data that you have available, both at the domain level, the tenant level, and at the tenant context level. Some of these tools and mechanisms that we've talked about, fine-tuning, RAG, Bedrock knowledge bases, and agents. And it's working backwards from the use case and asking, what data do I have? Do I have the data I need for this use case using generative AI? If not, how can I get that data? What do I need to do to prepare that data? And how do I stand up these tools in my architecture? So I'm going to hand it off to Todd to take the story forward.
Thanks, James. And I will just re-emphasize James's point here, which is, to me, when we put all this together, it's like these tools are all awesome and great, but still somebody in your organization is going to have to go, you've got to go figure out, where's all this coming from? Where's my fine-tuning coming from? Where's what RAG formula, which tools? Like, I wish we could tell you just go do X or Y, and that's the packaged way to do it. It's not. You have to sort of go figure out what's going to work best for you. Now, in addition to sort of like, great, we can do these tenant refinements, we can introduce all these new constructs. When we introduce new constructs into any SaaS environment, we're always going to have to ask ourselves, like, what are we doing to make sure one tenant can't access another resource of the resources of another tenant? Like, that's just foundational to SaaS. And now we have all these new Gen AI constructs introduced into our universe. And if we look at like the pieces James talked about here, right? We have these fine-tuning endpoints now, these models that are available to us. And each one of those models are associated with individual tenants. We have whatever these RAG sources are, these vector databases or DynamoDB tables or whatever it is we chose to use down in those environments. And even if they're deployed for individual tenants, they're not isolated, right? There's nothing on the surface that will prevent a microservice for crossing a boundary from tenant one's and tenant two's resources. We have to introduce something there, right? So we need something that will make sure tenant one can't see tenant two's RAG data, for example. And we also need something that makes sure that across these endpoints here, or these models, one tenant can't invoke another tenant's model, right? So just fundamental sort of tenant isolation, but an easy thing to overlook when you start wandering into generative AI here. So what does it look like? Well, the good news here is, like, if you've seen a lot of our talks on tenant isolation, or you've seen things we talk about a token vending machine and how to assume roles with IAM, we can still use IAM mostly here to secure a lot of these mechanisms and make sure that one tenant can't see another tenant's resources. And in this case, for fine-tuning, it's really straightforward, which is our tenants come in with their JOT token that has the tenant context in it somewhere within our SaaS solution. Some library, hopefully, or something of that nature, is going to go out and say, hey, there's a policy out there that is a policy that constrains access to different generative AI models here. I'm going to assume a role for that particular tenant, get back the credentials from that role, and then use that to go access and invoke the model that I'm interested in invoking. And if I try to invoke a model that doesn't belong to me, I'm going to get denied. So super straightforward, but something not to overlook. Now, when you look at it with RAG, it's a little more interesting because RAG is, we're not just have a model and a model ID and we just have to lock down that model ID. Now we have any number of different technologies and resources that we have to think about. So we could have, like James talked about, we could have OpenSearch here, we could have Pinecone here, we could have RDS in this world. And really this comes now back to the fundamental ways we think about applying isolation generally. One of your approaches is if your resources are siloed here for your RAG data, you can use just our like resource level isolation where you would just use IAM to say, hey, can you access that database? Generally, there's some IAM or some other mechanism there that at a resource level that you can constrain. Where it gets a little more tricky, and like James's example he had before, is when you get to item level isolation, where if the resource has tenants data or tenant items commingled together inside the same resource, now you have to figure out how to apply isolation at that level, and that's where your mileage might vary a little bit. So in some cases, IAM is your friend there, and you can do exactly what you want. In other cases, you will have to be creative about how you do isolation there. And if we look at isolation just for RAG data here, using IAM, same old formula. This is the diagram James had earlier showing all the different DynamoDB tables, but now with isolation layered onto it. We come in, our solution assumes role based on the tenant context, and now it's going to go out and essentially hit one of these tables. In this case, it's hitting the pooled table, which is where we had tenant data commingled together. Well, in that model, I have to have some notion of item level isolation, which is why it's handy that I picked DynamoDB here, because it supports item level isolation. So I can say, you can only see tenant 2's items in this table. Works great. If this were RDS MySQL, we'd be having another discussion. Postgres, it'd be row level security. There's other options you have to think about. And then we had the two siloed tables that James talked about, the ones with our golf and our tools bits in it. Now these can use resource level isolation. So nothing exotic, nothing wildly crazy here, but we really can't talk about multi-tenant SaaS, throw all these resources in this environment and not ask ourselves, how are we going to protect them? To me, the more interesting angle here, and the one that comes up over and over with customers, is like, what is tiering? What does it really mean to tier a solution in a generative AI experience, where I've used generative AI underneath the hood of my solution somewhere? Is it the same old thing I do for tiering already, and generative AI is just one more tool in the tool bag that I have to think about? Or does generative AI somehow change the way we think about how tenants consume our experience and how we control how they consume our experience? And we'll see how we measure how they consume our experience. So if we look at this at the simplest level, and we just said, hey, there's an operational view into this, and there's sort of a product view into this. At an operational level, if I have different tenants consuming somewhere in the back end of my SaaS solution, there's consuming Bedrock, I'm just operationally be concerned about, is one tenant imposing excess load on my system? That's just a core sort of SaaS consideration. I'm also going to be worried about it because even if I can support how much they consume, is what they're consuming affecting the experience of other tenants? So just to keep the lights on, I'm going to want to have some way that I control that. But then at the sort of product level of this discussion, I'm also going to say, I may not want to offer every single customer the same entry point and price point for my system. I may want to segment my offering into different experiences. So I may want to have a basic and an advanced and a premium tier tenant here, and basically say, hey, my basic tier tenants, your SLAs are going to look like X or Y and I'm going to constrain the degree to which you can consume Bedrock here. And this is partly, again, for health of the system and partly for noisy neighbor, but it's also a business decision, which is, I don't want the basic tier tenant who's paying me $50 a month, unlikely, but whatever they're paying me a month, to be consuming 80% of my Bedrock bill because they're just going crazy on the system and consuming it. Meanwhile, my premium tier tenants both being impacted by that tenant, but also maybe is consuming it even less. So I get all this sort of imbalance in the different sort of tiers of my system and the level of load they're putting on my environment. So you need this tool to do this. But the question is, how do you do this? And is it just the same old thing with Bedrock, or is there something more you need to think about? And it turns out there is something more you need to think about. So if we take basic, advanced, and premium tier tenants and they're coming in, we need to put something between those tenants and their consumption of Bedrock, because we need to be able to sort of intercept those requests and validate whether or not we're going to throttle them or not going to throttle them, or what are we going to do with them. So in this case, I've chosen Amazon API Gateway, and I will admit now that we are still figuring out there could be any number of different tools in that slot. But Gateway is one I'm familiar with, and it's an easy one to sort of describe this problem for. And here with Gateway, I'm going to process each one of these requests, and just like I would with classic throttling, I'll use the Lambda authorizer, and I'll look at this, and in reality, I can look at the frequency of your calls here as well. So I might use the classic sort of throttling, which is just you're calling too many times. That's going to get into my throttling story here. But also in my throttling story is the new twist, the new wrinkle, which is what's the complexity of the request you're about to send into Bedrock? Because if you look at these Gen AI solutions, the complexity of the tokens coming in and out, the size of them, the complexity of them, and the complexity coming out, those are the things that correlate to load for the service that you're consuming. So it's not just the number of calls you're making to it, it's the complexity of the calls you're making to it. So now we have to put complexity into the front door of this story, evaluate the complexity of the call that's coming in, and then create our authorizer policy, and then decide, are we going to let you flow through to the back end or not? So now we have a whole new set of things to think about. I could have a frequency set of policies and a separate set of complexity policies, or I could have some combination of those two things. How do we then find the boundaries here? Now that we're measuring complexity, where would the boundary of a policy be? Like, how do you decide how big or how complex something is to say you're a basic tier complexity, this is advanced tier complexity, or just how frequently are you submitting requests of a certain complexity size? Does that get you to an SLA? There's all kinds of bits you have to think about here. But my big thing is here, no matter what you do here, you have to do something. You're not just going to leave Bedrock wide open in your app and say to somebody, consume however much you want, all good. That's just not going to be a good idea. Now, a whole nother dimension of tiering here that is one that is an entirely different perspective on it, which is to say I've got basic and premium tier tenants here on the left-hand side. And then on the right-hand side, I've got all these different LLMs that are out there, right, that are available to me that all have their own sort of strengths, and they're all specialties and things they're good at or things they might not be good at. And could I, as part of my strategy here, choose to say the LLM that you get to use as part of my experience is part of your tiering strategy. So basic tier tenants get LLM 1, and premium tier tenants get LLM 2. And the assumption here is there's something about these LLMs that would make them more appealing at a higher tier than the lower tier. But that's where the hard part of this comes in, because what's appealing about it and why you might want to offer it to somebody at a higher tier is a it depends kind of answer. Like your domain and the nature of what you want to do with that LLM is going to have a lot to do with how you decide what's basic and what's premium here. But I still think it's a valid model. It just it depends on whether it'll apply to you based on what it is you're actually doing with your solution. Now, in terms of pricing here, pricing, people are coming at me left and right and asking me, like, what should the pricing model be? What's your guidance for pricing for SaaS providers? And I still think, again, an emerging space for which I think there's still lots to be learned. I would think the generative AI services themselves will evolve a ton in terms of how they approach pricing. But right now, if I were to say, what are the options? I think one way to look at pricing here is based on experience alone, right? I could say this whole model James described with RAG and fine-tuning, I could say my basic tier tenants, you all share one model, you all get the same experience, that's it. But my premium tier tenants will offer you per tenant customization. Or I could do something purely SLA, so throughput based here if I want, and say, I'm going to throttle you basic tier tenants at a certain level, but premium tier tenants, you get to consume more. By the way, nobody gets wide open. There's going to be throttling here no matter what, but premium tier gets to consume a lot more maybe than basic tier does here. And then the sort of last model, which is perfectly reasonable, imagine an environment where the nature of what's being asked of the Gen AI service under the hood is wide open and changing all the time, and I have no idea what the complexity of these, or, the input or the output of these requests is going to be, well, that means the cost could be changing wildly all over the place. I might do cost per inference here and just say, I'm going to correlate this very much to whatever the cost was on the back end for me to perform this task. I'm not a fan of like passing the cost of the infrastructure straight through in my pricing model, so I'd like to try to abstract that away a little bit, but you may still have to take this approach. And the real answer is, it's probably some combination of these things. Right? There's no one size fits all for everybody here. You're not just going to be in one of these buckets. You might need a mix of these things. And again, just, caveats are important here. I still think next year there'll be a lot more to say about this, but this is, I think, a reasonable starting point. The last bit here just on pricing models is, if we take classic sort of silo and pool models, we've always talked about like, you could have a full pooled environment where all tenants are sharing all things, and you could have siloed environments where tenants got dedicated environments, but they were all owned and operated sort of through one collective experience. What would that look like in a generative AI environment? Well, I could here have all my services shared, have this fully shared environment, and in this model say, you have to, everybody's sharing the same model. And in this model, I might do on-demand pricing, right? We have different pricing strategies that I can use. It'll all have to do, obviously, with how frequently this pooled environment is invoking it, because I could choose something other than on-demand here. But I also, like in here, there's no training cost for the model, because we're not doing anything specific to these tenants. And the general idea is like, on this side of the world, I'm trying to keep the experience pretty lightweight and maybe limit my costs if I can on the generative AI side. And then on the silo side is where I'm going to say, no, now is where you get all this rich model customization, right? So in fact, when you go to if you want to do model customization, you're going to fall into another bucket of price points and so on, just from the generative AI service. So no matter which silo pool or whatever you choose, if you're going to do model customizations, you are going to incur additional costs just and expectations from the Gen AI service. So here, though, now I can do things like configure provision throughput so that I can get a more predictable response from the environment. I'll get a slightly different billing model from this experience versus if I'm in the on-demand mode, the sort of the predictability of your experience is a little less easy to understand in that mode. The last bit of this section is did we lose the mic? Mic's cutting out on me. Here we go. Is cost per tenant. Like we talk about cost per tenant across all the content that we talk about because businesses just need to understand how much is it costing me per tenant, not just because for a billing reason. They want to know for analytics internally. Like I just want to understand how different tenants are imposing load in my environment. I want to be able to do analytics around that. And oh, by the way, I could also use that as part of my pricing story. And so I very much encourage people to go out and meter the consumption of these generative AI services part of their solution. So here, got an app playing, got services coming in, and I'm about to make a request to the Gen AI service. I'm going to intercept it here, and I'm going to evaluate the complexity of the request. I'm going to remember that, and then I'm going to send the prompt off to Bedrock. And now when I come back, I also have to evaluate it on the way out. So when I evaluate it on the way out, I have the complexity of the request coming in, the complexity go out. Now I'm going to record that and capture that. So if you've seen in our examples, we've talked about you need a metrics and analytics service running in your control plane of your SaaS environment. You want to aggregate all that data here and then choose how you're going to use it. Is it just for internal analysis? Is it for billing? What's it used for? That's all up to you. And you could argue, you could evaluate and record it on the way in and then evaluate on the way out separately as you want it. You could have those be entirely two separate events. But the key thing is you need this data and you need to be evaluating the complexity. And this probably overlaps with the throttling evaluation of complexity. There may be some bits of code you could share there. Okay, James, I'm going to hand over to you real quick. Talk about tooling.
All right, thanks, Todd. So the reason why we put this section in here for tooling is there's a lot of productivity gains that you can realize by using a lot of the work that's being done to develop open source frameworks, various tools, productivity gains with these different tools that, so you're not building things from the ground up. There's a lot of activity going on in this space. These are just a few. There's really tons of different projects out there that are actively being worked on, but One of the earliest and most popular frameworks out there is LangChain. It's an open source project that is in Python and JavaScript. And it creates abstractions and implementations and wrappers around the most common Gen AI development patterns that you've seen. So we've talked about using prompt engineering with RAG. There's the chain of thought that we talked about with agents. LangChain has its own agents capability built into it that you can use. Chains is a way to chain multiple calls together to LLMs to have some desired outcome. It helps with prompt engineering, prompt templates. So it's really a productivity gain tool that allows you to develop Gen AI applications more quickly. LangChain also has implementations around several AWS services, including Bedrock. So you can use LangChain to construct a Gen AI application around Bedrock. Other AWS services, Kendra is in there as well as a RAG source. Amazon Personalize is in there as a RAG source, as well as other sort of foundational or infrastructure services, such as like Elasticache for retrieving memory for a chatbot experience. So LangChain is a great library. There's a lot of activity going on there. Expect it to continue to evolve. Hugging Face is a community and platform to help developers build, train, and deploy machine learning models. And it provides also a lot of libraries. It has thousands of open source libraries and foundation models, or thousands of models that you can bring into SageMaker through SageMaker Jumpstart. And so that's a way to quickly spin up some of these open source models in SageMaker. Of course, that comes with more responsibility. You have to then configure and maintain and operate that. The pricing model is a little bit different there versus the more consumption token base that we talked about with Bedrock. But nevertheless, if you really want more control over your Gen AI experience and you have machine learning expertise, using Hugging Face with SageMaker Jumpstart is a great option to consider. And then finally, we've talked a lot about Bedrock today and some of the tooling on top of Bedrock, not only just being able to access these foundation models, but also being able to build agents and knowledge bases. Guardrails is an exciting announcement we had this week for doing content moderation around prompts, input and output prompts. So there's a lot going on there with Bedrock. A really quick look at what LangChain looks like in action. This is sort of a contrived example here. We have some code where we're bringing in, this is in Python, we're bringing in Bedrock through LangChain. We are creating inference parameters that we're going to pass. These are the arguments we're going to pass to the foundation model. We're going to create a client we're using Anthropic Claude Instant here. And then we can invoke, with a prompt template, we can build a prompt and then invoke the model to get back our response. So this is how simple it is in LangChain to be able to interface with a Bedrock foundation model. An embeddings-based example, so Bedrock embeddings is another class in LangChain that you can use. Using the Titan embeddings model in this example, you can generate the embeddings and then use them to index, say, in the OpenSearch index that we saw earlier. Back to you, Todd.
Cool. Thanks, James. Okay, just quickly here, we'll wrap up. Just a few takeaways that will hopefully be some fine points we would like to make before we wrap up. Hopefully you can see here, like this whole notion of fine-tuning and RAG, they're like super powerful constructs that could really have a lot of multi-tenant implications for you. Yes, they're good in general, but they're especially valuable in this area where we're trying to figure out how to offer tenants different experiences. And then I think back to this point, I think I've already drilled it down too much here probably, but figuring out how and where to customize your system, what are the right points to introduce RAG and introduce fine-tuning, and where's that data going to come from is a big part of this problem, and you definitely want to start there and work backwards. And then these foundational SaaS concepts, silo, pool, isolation, like all these things that we always talk about, you should see that they overlay some of this, or intersect at least with some of the concepts here. So don't forget that you still have to be thinking about those fundamental principles as part of biting some of this off. Noisy neighbor, like that whole notion of throttling should be a big area for you to look at as part of this. And I sort of, throttling and pricing, basically all of this is influenced by complexity. So this whole notion of complexity and of what's the sort of complexity of my prompt, what's the complexity of my output, that has this cascading impact across how you throttle, how you build pricing. It have all kinds of influences that you want to think about here. And then you have to sort of figure out which of the deployment strategies, like silo and pool, and do you want to be provisioned, or are you going to be on demand? Like, you have to sit down and figure out which combination of those things are going to match your workload. Are we light on the way we make requests so we could be an on demand, or we need provision? Do we want to do all this tenant customization? Well, if we do that, we have to find out which flavor of Bedrock is going to be best for us, and so on. And then that little snippet of LangChain, even though it wasn't super multi-tenant SaaS, is a reminder that the tools here are your friend. Their tools can make a whole lot of this easier. So I highly encourage you to sort of lean into the tools and figure out what works best there. Breakout sessions that have already all occurred for the most part. I don't know that there's any left, but if you just wanted to go find them on video after the conference, here's a list of them, and then I'm just gonna snip through these because you don't need those. And that's it. So thanks for turning out. Really appreciate you being here. Thanks, James, for your help. So it was great presenting this content for the first time. We'll do questions over here if you have questions.